This video looks at sketching curves, and our learning objective is to sketch curves associated with power functions and polynomials up to and including degree 4, find stationary points and local and global maxima and minima with and without technology. We'll be focusing on without technology, and to examine behaviour as x goes to infinity and x goes to negative infinity. Now, when graphing polynomial functions, we need to feature 4 major things: the basic shape, the y-intercept, the x-intercept or x-intercepts, and the stationary points. Starting with stationary point, we know that the stationary point is where the graph momentarily stops rising or falling, so the gradient is 0. So dy dx equals 0 at a stationary point. Now, there are 4 types of stationary points. First 2 you're quite familiar with already. Our local minimum or local maximum. For our local minimum, either side of that turning point, our gradient is negative to the left and positive to the right. So we go from negative 0 to positive, and 0 being that horizontal line if we drew a tangent. So if we look at a sine diagram, we're going from negative to 0 to positive, and you can see that shape of the curve. For our maximum turning point, or our local maximum turning point, we are going from a positive gradient to a 0 gradient to a negative gradient. So when you look at your sine diagram, you are going from positive to 0 to negative, and again you can see that shape from the sine diagram. Another way to think about it is when we were talking about increasing and decreasing, where is the function increasing? With our local minimum, it is decreasing, it is 0, it is then increasing. For our local maximum, it is increasing, it is 0, then it is decreasing. Our next 2 types of stationary points are our horizontal points of inflection. So for those, and you should recognize these from a cubic, so y equals x cubed or y equals ax cubed, we are going from, for a positive stationary point of inflection, a positive gradient to a 0 gradient to a positive gradient. So either side of that stationary point, our gradient is positive. So when we look at our sine diagram, we're going positive, 0, positive. In contrast, the negative stationary point, it is going from a negative gradient to a 0 gradient to a negative gradient. So our function is decreasing, it is then 0, and then it is decreasing again. So our sine diagram, negative, 0, negative. And again, from our sine diagrams, you can see the shapes. So let's do an example. This says for the function y equals 2x cubed minus 3x squared minus 12x minus 7, find the stationary points, determine the nature or type of each stationary point, and sketch the graph. Now, the first thing I do when I look at this is I go, it's a cubic. So I know my graph is either going to look like that, or it is going to look like that. I need to know the nature of my stationary points to know, well, first of all, I need to find out what the stationary points are. Then I need to determine their nature to know which of those 2 graphs I have. So my part A is to find those stationary points. Now, as stationary points, we know that dy dx has to equal 0. So we find dy dx. So dy dx equals 6x squared minus 6x minus 12. We then let that equal 0, and we factorise to find out where our turning points are. So we need our x values. So bring out the 6, we've got x squared minus x minus 2. We don't have to worry about the 6 because I can divide both sides by 0. So I now factorise the x squared minus x minus 2. So that is x minus 2, x plus 1 equals 0. So x minus 2 has to equal 0, x equals 2, x plus 1 equals 0, x equals negative 1. Okay, so now we've got where our turning points are. We need to find the y value. So when x is negative 1, we've got y equals 2 times negative 1 cubed minus 3 times negative 1 squared minus 12 times negative 1 minus 7, which is 0. be careful of the negative one when you're working this out, otherwise you can get it wrong. Remember, a negative squared is a positive. When x is 2, we get y is 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 minus 7, and that gives us negative 27. So that's the point 2, negative 27. We now need to work out our sign diagram for this. So do it in one, make your life easier. So you don't need to do two sign diagrams. So what we're trying to do is find the nature of those stationary points. So I've got my x value, 1 at negative 1, 1 at 2, and we need to find our gradient at either side. We know it's 0 at negative 1 and we know it's 0 at 2, but we need to know what happens either side. So when picking those other values, just pick something either side. Always pick 0 unless you've got a turning point at 0, because that's easy to plug in, and then maybe go 3 and negative 2. So you're finding what the gradient is at these points. So at x equals negative 2, dy dx would be 6 times negative 2 squared minus 6 times negative 2 minus 12. So I know without even working that out that that is going to be a positive answer, because 6 times 4 is 24 and negative 6 times negative 2 is positive 12. So that's an easy way to do it without actually working out the answer, but you can work it out. So I know my gradient is going to be positive at negative 2. I then go, well, what happens at x is 0? My dy dx is going to be negative 12. Remember, I'm plugging in to this dy dx here. Okay, just in case you're lost. So that gradient is a negative, so my sign diagram is going to negative, and I already can see the shape, but I would still work out x is 3, because you never know, I could make a mistake, and I could be thinking I know what it is, and my mistake's leading me astray. Now 6 times 9 is 54. There is no way by taking away 18 and negative 12 and minus 12 that I'm going to get a negative answer, so this is going to be a positive gradient. So I know up here that it's going to be positive, but you can work it out, and it'd be 24. Now if I move this 2 value, the 0 further down, you can see that's the shape from the sign diagram, so we know it's that cubic there. Okay, so let's finish our answer here with maximum turning point at negative 1, 0, minimum turning point at 2, negative 27, because that was a question in itself. And let's move on to the last part, which is sketching the graph. So I've summarized here to make it easier. We need to find our y-intercept. So for y-intercept, x is 0. So y is going to be negative 7. So 0, negative 7. On my graph, I've already labelled that, so I cheated. Now we've got x-intercept. So x-intercept is a little bit harder because it's a cubic, but this will be good revision for Unit 1. You could use your calculator to find the x-intercepts, but let's assume it's a non-calculator exam. It's a Unit 1-2 exam, and we need to find our x-intercepts. So I know that there's a maximum turning point at negative 1, 0. Okay, so this is key information here. That means I have a repeated root at x equals negative 1. So when I factorize, I know that I have x plus 1 all squared, and then something else, which might be ax plus b. Okay, so I'm taking a shortcut here in regards to not needing to do long division. And we did do this in Unit 1. So if I expand my left-hand side, I get x squared plus 2x plus 1, ax plus b, and then that expands to ax cubed plus bx squared plus 2ax squared plus 2bx plus ax plus b, and that has to end up equaling that right-hand side. So I can now equate coefficients. I've got ax cubed has to be 2x cubed. So I know that a equals 2. And then if I look at something, or what else I've got to be able to equate, I can either look at my x squared coefficients, or I can look at my x coefficients. Not going to really matter. If I look at my x squareds, so I know that bx squared plus 2ax squared has to end up equaling negative 3x squared. A is equal to 2, so bx squared plus 4x squared has to equal negative 3x squared. Factorise that x squared out, you've got b plus 4 has to equal negative 3x squared. So b plus 4 has to equal negative 3, b has to equal 7. So that means I now have x plus 1 all squared, and then 2x plus 7 is factorising it. So I know I've got x-intercept as x equal negative 1, and the other one is 2x plus 7 has to equal 0, 2x equals 7, x has to equal 7 over 2, or 3.5. So if I come back to my graph, 3.5 would be about there. So I have x-intercept there, 3.5, and another one at negative 1. I know I have a maximum turning point at negative 1 and a minimum turning point at 2. And that minimum turning point is not there, which is why it didn't make sense. It is at 2, negative 27, which is down here somewhere. So that's my minimum turning point. Label my turning points in, and then it's a matter of joining the dots. So something like that. In an exam, draw it in pencil, go over it once you're happy in pen. Label my graph, y equals 2x cubed minus 3x squared minus 12x minus 7. So the toughest part of that was actually finding the x-intercepts. Again, you could have used a calculator. I personally, if I was graphing, would leave that until something, like if I was to algebraically determine x-intercepts, I would leave that as the last thing I've done in an exam. So if I don't get back to it, at least I've done the majority of the question. Moving on to the next example, sketch the graph of g of x equals x squared, 4 minus x squared, clearly labeling or indicating all stationary points and axis intercepts. So it does say both axis intercepts nicely. This is already partially factorised for us. We can easily factorise the second part as 2 minus x, 2 plus x. So straight off, I'm finding my x-intercepts. So x-intercepts are when g of x equals 0. So that means x squared, 2 minus x, 2 plus x has to equal 0. X equals 0, 2 minus x equals 0, 2 equals x, and 2 plus x equals 0, x equals negative 2. Okay, so may as well just find my y-intercept while I'm at it. So y-intercept is when x is 0, g of 0 is going to be 0. So 0, 0. Okay, I should write out my x-intercepts probably. So I've got 0, 0, 2, 0, negative 2, 0. Stationary points are when my derivative equals 0. Now, it's easiest to expand the brackets first. So g of x equals x squared 4 minus x squared, which is 4x squared minus x to the 4. And the derivative of that is 8x minus 4x cubed. So So I need to find out where that equals 0. So 8x minus 4x cubed equals 0. Bring a 4x out. I get 2 minus x squared equals 0. Bringing in your knowledge of square roots. Square root of 2 minus x. Square root of 2 plus x equals 0. And come up here. So we have x equals 0. We have square root of 2 minus x equals 0. X equals square root of 2. And we have square root of 2 plus x equals 0. X equals a negative square root of 2. I then have to find my y values. So we already know that g of 0 is 0. G of the square root of 2 is going to be square root of 2 all squared. 4 minus the square root of 2 all squared. So that gives you 2 all outside of 4 minus 2, which is 2 all outside of 2, which is 4. So we've got the square root of 2, 4. This one was 0, 0. And then we need g of negative root 2. That's going to equal negative root 2 all squared, bracket 4 minus negative root 2 all squared. It's going to be exactly the same value as for the positive because these negative root 2 all squareds give a positive answer. So I've got negative root 2, 4. Okay, so I've got stationary points at 0, 0, negative root 2, 4, and root 2, 4, and I need to work out their nature. So now to find the nature of the stationary points. So we know the gradients are 0 at negative root 2, positive root 2, and 0. We need to pick points either side. Now you need to know what root 2 is, which is 1.73, I believe, but put on your calculator and check. Oh, it's actually 1.41. So that means we could go from negative 2, positive 2, which are either side of negative 1.41 and 1.41. We could go 1 and negative 1, either side of the 0. Okay, so working out the gradient at those points. The gradient at negative 2 is going to be 8 times negative 2 minus 4 times negative 2 cubed, which would be positive, and plug in your calculator at 16. So positive gradient there. The gradient at negative 1 would be 8 times negative 1 minus 4 times negative 1 cubed, which would be negative, plug in your calculator, get negative 4, so that means it goes like that. Gradient at 1 would be 8 times 1 minus 4 times 1 cubed. 8 minus 4 is 4, so that's positive. And then gradient at 2 would be 8 times 2 minus 4 times 2 cubed. That's definitely going to be negative. And at 16 minus 4 times 8, it's negative 16 if you go on your calculator. So it's negative. So if I move this point here like that, you can see that shape. Okay, so now we can go to our sketch. We had x-intercepts at negative 2, 0, and 2. We have turning points at 0, 0, and that's a minimum. At negative root 2, which is negative 1.4 and 4, so we'll make that the 0.4. It's around about there. And the same at positive root 2, 4. So this is a negative root 2, 4, root 2, 4. and they're both maximums. And label your graph. And you're done. So practicing exercise 19D, page 655, and you'll have the rest of this lesson and next lesson to do that.